In this video, I want to talk about the trig identities. So just here, I have what's on your formula sheet. So we've got a pile of trig identities here, but not all of them. So these first two are what are called our reciprocal trig identities, and that's two of them. So we've got cosec theta and sec theta, and the other one that we know is cot theta is equal to 1 on tan theta. So they're what's called our reciprocal trig identities. Our next one that we have is this one here, or these two here, I should say. So we have tan theta equals sine theta over cos theta. So we've been talking about this one a little bit, but just to reinforce where it comes from, we know if we're talking about a right-angled triangle that sine theta is opposite over hypotenuse, and that cos theta is adjacent over hypotenuse. So if we were to go sine theta divided by cos theta, we're going to end up with opposite over hypotenuse divided by adjacent over hypotenuse. Or if we rewrite that, we'd have opposite over hypotenuse times hypotenuse over adjacent, because we're multiplying by the reciprocal of that bottom fraction. And then our hypotenuses would cancel out, and we'd just be left with opposite over adjacent, which we know is tan. So sine theta over cos theta equals tan theta. Now, if that's true, if tan equals sine over cos, then because cot is the reciprocal of tan, that means that cot is equal to cos over sine, so the reciprocal of that. So those are called the ratio identities. We've got our reciprocal identities and our ratio identities. So our next one down the bottom here is what's called the first of our Pythagorean identities. So we've got sine squared theta plus cos squared theta is equal to 1. Now, if we have a look, if we've got, picture our unit circle again, or actually it doesn't have to be a unit circle, it can be any circle with a radius r. If we've got a point on the circumference of that circle with coordinates x, y, then because it's the coordinates on the circumference of a circle with radius r, and that circle is centered at the origin, we know that any point on that circle will satisfy the equation x squared plus y squared is equal to r squared, because that's the equation of a circle with radius r centered at the origin. Now, if we go through and divide everything by r squared, we're going to have x squared over r squared plus y squared over r squared is equal to 1. And when we were talking about our unit circle before, if we had our little triangle in there, we were saying that sine is equal to the y coordinate, because that's our opposite side, divided by the radius. So y over r that we have here, that's sine. So that means that this whole term is going to be equivalent to sine squared theta. And this one, x over r, our x coordinate divided by our radius, that was equal to cos. So x over r all squared is going to be equal to cos squared theta. So we're going to have cos squared theta plus sine squared theta is equal to 1. So that's our first Pythagorean identity, and that's the only one that you get on your formula sheet. But we can figure out a few others from that. So if we were to go through and divide every term in there by cos, we'd end up with sine squared theta over dividing by cos squared. So sine squared theta over cos squared theta, plus 1, if we divide that by cos squared theta, is equal to 1 over cos squared theta. But because sine over cos is equal to tan, that means that sine squared over cos squared is equal to tan squared plus 1 is equal to, and we've got the reciprocal of cos here, so that's going to be sec squared theta. So that there is our second Pythagorean identity. And if we go through and do the same thing, but we're going to divide by sine squared theta this time, I'm running out of room a little bit, but we're going to end up with 1 plus cos squared theta over sine squared theta is equal to 1 over sine squared theta. Then that's going to leave us with 1 plus, now cos over sine up here we know is equal to cot, so this is going to be equal to cot squared theta equals, and 1 over sine, we know that cosec is the reciprocal of sine, so that's going to be cosec squared theta. Okay, so those are our 3 Pythagorean identities. You only get the first one in your formula sheet, but you can figure out the other 2 from there. The last trig identities that you need to know are the complementary identities. So I've drawn a little right angled triangle here. If this angle in here is theta, then this angle in here has to be 90 minus theta. So that's from the angle sum of a triangle. So these 2 angles, our 90 minus theta and our theta, are what are called complementary angles. All right, so if we have a look at our 3 sides of our triangle now, we're just going to call that A, B, C. We're going to have a look at the complementary ratios. So if we have cos of 90 minus theta, in here, that would give us, so we're going from this angle, cos is adjacent over hypotenuse, so that's B over A. I'm just going to write that underneath. That's what we're aiming for. Now that's going to be equal to sine theta, because sine from this angle is opposite over hypotenuse, which is B over A as well. So cos of 90 minus theta is equal to sine theta. Our next one is if we have cot of 90 minus theta. If we look here, cot is the reciprocal of tan. So instead of going opposite over adjacent, we're going adjacent over opposite. We're going from this one here. So adjacent is B and opposite is C. So that's equivalent to B over C. Now that's going to be equal to tan theta. So if we go from here, we're going opposite over adjacent, which will give us B over C as well. So cot of 90 minus theta is equal to tan theta. And our last one is cosec. So cosec of 90 minus theta is, if we go from here, cosec's the reciprocal of sine. So instead of being opposite over hypotenuse, it's hypotenuse over opposite. So we're going to go from this angle again. Hypotenuse is A, opposite is C. So we're going to have A over C. And that's going to be equal to sec of theta. So sec is the reciprocal of cos. So instead of being adjacent over hypotenuse, we're going hypotenuse over adjacent. So from theta, we're going to have A over C. So those there are our 3 complementary identities. All right, so that's just running you through what the identities are. In our next video is going to have a look at how we can use them.